and today I'm going to be doing a question for Po-Shen live application. So let's get started. So the question is, how many 5-digit positive integers exist where the digits are non-increasing from left to right? For example, 87743 and 10,000 fulfill the conditions, 78987 and 33429 do not. So the first thing we're going to do is we're going to look at the question and we're going to see it's all words, right? There's literally no math. So we can just ignore this original question and just try to translate this into math. So we have 5-digit positive integers, that's A, B, C, D, E, and they're non-increasing. So non-increasing means A is greater than or equal to B, B is greater than or equal to C, and we just have this long chain, right? And we also have the conditions that E is at least 0, right? -1 is not a digit. And at the same time, 10 is not a digit. So 9 is at least A, okay? So now we just need to count the number of ways for 9 to be greater than or equal to A, all the way down to E, which is at least 0. But we also need to impose the additional restriction to subtract 1. Because if all of these are 0, this is never going to be a 5-digit integer, right? So our first step here was essentially to convert word to math. And I am going to keep a mental note here to subtract 1 when we are done, right? And this is just some personal preference that I do when I am in a contest, because you do not want to forget all these extra conditions when you are finished with the question, because you are going to spend 20 minutes, your answer is 3,500, 900, whatever, and you forget to subtract 1, okay? So, that being said, we can now move on to the next step of the question, okay? So our next step is to try and take this new condition and we are going to look for irregularities, okay? Irregularities are just anything that makes your question annoying. How can you understand this question? How can you make it less annoying? So we are going to try to turn these into regularities, right? So when we look at this, it's a very long inequality chain, and that's kind of ugly. So I am just going to first, and I haven't even done anything yet, this is just a preliminary step. I'm going to convert all of these to the base inequalities. So 9 is at least A is at least B, all the way to E is at least 0, right? And so we see here, we have all of these variable left-hand sides, right? And we also have all these variable right-hand sides. And so the reason this is annoying is because when we change a right-hand side, let's say we work upwards, right? So we pick the value of E, maybe it's 1, and then we're actually restricting the value of D. And after we restrict the value of D, we restrict the value of C here. So we're essentially moving up, and then we move up, and we just continuously restrict the value of the next variable. And so the way we can fix this is we can say 9 minus A is at least 0. A minus B is at least 0. B minus C is at least 0. All the way to E is still at least 0. Okay? So if this is confusing, what I have essentially done is I have taken the irregularity of variables on the left-hand side and the right-hand side. And I have essentially converted this to a regularity where all of the right-hand sides are equal. So you can see here, all of these are going to be equal to 0, right? So first step, word goes to math. We need to keep track of this. And then irregularities go to regularities. And our last step is going to be stars and bars. Actually, since I'm left-handed, I'm just moving to this side. Okay, so we have stars and bars. So the way stars and bars works is, let's take these 6 variables, 9 minus a to e, and move them over here. And for the sake of clarity, I'm going to say 9 minus a is x1, a minus b is x2, and e is x6. So we're just going down and reassigning the variables. So these are all at least 0. And once again, this is easy because it's much better than having all these confusing inequalities here when everything is just at least 0. Okay, so here we go. We also have the condition that if we add these up, it's equal to 9, right? And the reason this happens is because we took all of these pairwise differences and all of these variables in between occur once positive and once negative. So obviously they'll just cancel. So anytime we make some sort of transformation from 9 greater than or equal to a to 9 minus a, we always have to check if we're adding in any additional restrictions. And in this case, we are. So we have x1 plus dot 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 x6 equals 9, and they're all at least 0. Okay? So I'm just going to quickly introduce how you can use stars and bars to solve this new question. So let's say you have 5 dividers and you have 9 balls. 1, 2, 3. Okay, so 9 balls, 5 dividers. So you can see these 5 dividers are going to turn this number line, or just line segments, into 6 regions. 1, 2, 3, 4, 5, 6. And we can essentially just take some of these balls and put them into each of the regions, right? And our numbers x1 to x6 are just going to be the number of balls in each of the regions. So what I am essentially doing is, I have all the 9 balls. Maybe I can just put them in a line like this. And you can imagine these dividers are just going in and dividing it arbitrarily. So I have 5 dividers, and for example here I have 3, 1, 1, 1, 1, 2. And this gives me a unique 9 minus a to e. Okay? So now I just need to figure out the number of ways to order 9 balls and 5 dividers. So I am just going to erase this so I have more room. And remember, we have 9 balls and 5 dividers. And this is also known as stars and bars because the balls are stars and the dividers are bars. But it's called like a million names, so that doesn't really matter. Anyway, we have 9 balls, 5 dividers. This is 14 objects. So let's say we have 14 spots, right? These 14 spots, we can choose 5 spots for the dividers. And so we have the operation 14 choose 5 here. This is going to be 14 times 13 times 12 times 11 times 10 over 5 times 4 times 3 times 2 times 1. Now how did I get this number? So the way I got this number is I have 14 spots for the first one, 13 for the second, 12 for the third, 11 for the fourth, and 10 for the fifth. This is just me selecting all the ways that I can position these 5 spots. But now, if I select the first 5 spots in this order, so the first gets the first spot, the second gets the second spot, on and on, then this is the same as me just selecting 5, 4, 3, 2, 1, right? I have 5 factorial permutations here. So I need to actually divide by 5 times 4 times 3 times 2 times 1. This is going to be 120. I can actually cancel 120 with the 12 and the 10. So now I am left with, and let me just go to the middle, 14 times 13 times 11. And we also have -1 when we are done, right? So I subtract 1. My answer is 2001. And we are done. And so I have word to math. Keep track of this. Irregularities go to regularities, and then stars and bars.